Okay, here's the AP Classroom work for Chapter 9. Number 1, a researcher is conducting a study of charitable donations by surveying a simple random sample of 500 households in a certain city. I'm going to stop right here for a second. You should see two answers you can immediately get rid of. This doesn't make sense and this doesn't make sense. We don't do null is always P equals. Never less than or greater than. So D and E are automatically out. So now all we're looking at, are we talking about greater than, different than, or less than? So the researcher wants to determine if there's convincing statistical evidence that more than 50%. Wow, that did a whole line. More than 50%. It's this one. Done. Don't even need to do anything else. Don't even need to read the rest of the question. Okay, 2. A p-value for a one-sided t-test is 0.10. T-test part doesn't matter here. We do z-test right now, but this is just to illustrate a point. If it had been two-sided, what would the p-value have been? Well, one-sided means they're doing like this just side, and that's 0.1. Oh, well, the two-sided just adds the same thing on the other side. That's also 0.10, so our probability jumps up and doubles. That's all you got to do. Okay, number 3. In a survey of a random sample of 1,045 young adults found that 60% do not have a landline phone number. Hypothesis test will be used to determine if the convincing statistical evidence that more than 50%. So this is P hat, 60%, and this is P, and this is N. So we want P hat minus P over P times 1 minus P over N. So we want 0.6, 0.5, and then these both should be 0.5s. So 0.6, 0.5, 0.5, 0.5, C. Yeah, these would be out because they start with 0.5. This is out. Should have just crossed this one out from the beginning. That top part right there doesn't make any sense. And here they're using 0.4 and 0.6, which comes from P hat, not from P. Okay. Question 4. Experimenter conducted a two-tailed hypothesis test on a set of data and obtained a p-value of 0.44. The experimenter had conducted a one-tailed test in the same data. Which of the following is true about the possible p-values the experimenter could have had? Now this one's a little bit weird. You might want to think if they were doing a one-sided, it automatically goes down to 0.22, and that does make some sense, but we got 3 of them with that. Here's where it gets a little weird. So a two-tailed hypothesis is 0.44. That means there is 0.22 there and 0.22 there. So the idea, though, is we don't know if they're talking about this would be not equals to. Okay? So the problem is we have these things right here. So there's 22% this way or 0.22 this way, and there's 0.78 that way. So they could have gone from P, an alternate of being P equals not equal to a number, but they could have done the alternate being P is greater than that number or P is less than that number. And we're not told which one. So they could do one where they only get this, but if they did greater than, they'd get that way. They could do one where the number is over here and they only get the 22%, but they could do less than and they could do that way. I don't know why it keeps doing that. I apologize. But that means we get this one. That one's a rough question. That's a weird one with this 0.78 there. And I keep getting that little glitch. Apologize. Okay, question 5. To investigate whether more than half of the adults in the country, so more than half, that means P is 0.5. And I still get that little thing. researchers surveyed a random sample of 1,600, and of those, 1,280 responded they would be fearful of riding a self-driving car. So we need 1,280 over 1,600. And honestly, we can look at it. I'm assuming that's going to come out to 0.8. So that's p hat. This goes to what I did before. We should have 0.8 minus 0.5 over 0.5, 0.5, and then 1,600. And that looks like that guy right there. This one is out because it's using this number down here. This one doesn't make any sense because it's not a 2 sample. This one has the 2 backwards, so that's out. This one also has the 2 backwards. So we're down to A and B to begin with, and A uses the wrong numbers in the standard deviation part. Okay, question 6. A research organization reported that 41% of adults who were asked to describe their day responded that they were having a good day rather than a typical day or a bad day. To investigate whether the percent would be different for high school students. So that means this is our assumed P. To investigate whether there's for high school students, 600 high school students, there's N, were asked to describe this day. 245 reported they were having a good day rather than a typical or bad day. The data provided convincing evidence would be different, not greater than or less than, so different means not equal to. Now, we're going to need the good old calculator here, so let's bring it up. And we're just going to go to a new document, and calculator is fine. So we're going to a 1 sample, 1 prop z-test, statistics, stat tests, 1 prop z. And our P naught was 0.41. And then we had, what, 245 out of 600. And we want it to be equal. And we get a p-value of 0.93. So ridiculous. Yeah, I mean, we were barely even away from the mean. Yeah, it was like 41%. Well, we're basically at 41% there. So we got a p-value, an extremely high p-value. So it's not less than, or any reasonable significance levels are like 0.1, 0.05, maybe 0.01. And our p-value was 0.93. So it's above all those. We don't want less than. So yeah, it's greater than a significance level. So we have a high, so we don't need the yeses. And no, because it's greater than any reasonable significance level. Okay. And why did that happen? Okay, a police officer uses a motion detector to indicate whether a car is traveling faster than the speed limit. A speeding ticket will be issued to the driver of the car if the officer believes the driver is speeding as indicated by the detector. Situation similar to using a null and alternative hypothesis. So the power of the test is finding evidence for ha given it is true. So the driver issued ticket and they were actually speeding. So the probability of issuing with a driver who is speeding, that sounds good. Probability of issuing a driver who is not speeding, nope, that's not the power. Yeah, probability of not issuing a ticket, nope, we wanted the probability of issuing. Probability the motion detector is working correctly, no, it's just straight up this. Because we don't know about it, the power only is the alternate, and we don't know anything about not issuing tickets when it's not speeding. Okay, statistical test involves the following null and alternative hypothesis. Type 2 error. So a type 2 error is failing to reject and no evidence but the ha is true. So we failed to reject, so that means these can go. We're not rejecting the null. We fail to reject the null hypothesis when the population mean is no, because this is the null hypothesis. So failing to reject the null hypothesis when the population mean is greater than, when that happens. Yes, there we go. Is we fail to find evidence for the alternate. So we fail to reject the null when the alternate is actually true. All right? Did I skip over another one? Yes. University will add fruit juice vending machines to its classroom buildings if the student body president is convinced that more than 20%, so that's probably going to be P. A random sample of N students will be selected to ask whether they would use the vending machine. A large sample test for the proportions of the significance level at 0.05 will be performed. The null hypothesis of that the proportion of all students who would use the vending machine is 20% will be used against the alternative that's more than 20% of all students. For which of the following situations would the power of the test be highest? So what we want to increase power, we want higher sample size. We're not changing this. If this went up, we could do that. Nothing is about that. And we want to be up the distance, from the null, which is 0.2. So we want to be as far away as we can from that with the highest. So here's our two largest sample sizes. Well, that and that. I want this one. I want to be as far away from 0.2 as I can. So E. Now, how you actually get it to come out that way is a whole different story. Okay. The editor of a local newspaper wants to know whether readers would be willing to pay an additional $1 per month for their monthly newspaper subscription in exchange for an extra weekly section featuring stories about local businesses. Plan to survey a random sample of readers, and if the editor finds convincing statistical evidence that more than 75% of readers support the change, the editor will implement the plan starting the extra weekly section. In the context of the situation, a type 1 error. So and we want it to be greater than. So a type 1 error is we reject and have convincing evidence for the alternate, but we shouldn't. So this should be true. So if they find evidence in this, they implement. So they are implementing the plan. So that, we like that, decides to implement, decides to implement, decides to implement, decides not to implement, decides not to implement. So those are out. When the actual percentage is greater than, no, we want equal to. So greater than, not greater than, or less than. Well, we don't want any of that. We just want the not greater than. Like, those are the only two options. Less than, I don't even know, less than 50%. Heck, I don't know where that came from. That's just a random throwaway thing. So yeah, that's got to be B. The null has to be true. So it's not greater than that. Okay. Which statement about the power of a significance test is true? Let's see, a test performed at a significance level of 0.01 has a higher power than the test performed. Nope, the higher the significance level, the higher the power. Okay, so A is out. And why would it do that to me? So A is out. B, if the probability of a type 1 error is decreased, the power of the test is increased. No, type 1 error and type 2 error, because I mean, to reduce the probability of a type 1 error, you would reduce alpha. You would reduce the significance level, which would reduce the power of the test. So no. Power of the test is equal to the probability of making a type 2 error. No. It's probability of type 2 plus power equals 1. So they're not necessarily equal. Power test is independent of the sample size. No, if we increase the sample size, we increase the power. Power test in a particular parameter value increases as the distance from the hypothesized parameter value increases. Yes, that goes back to this one up here. The farther away we are from the null value, the more likely we are to find evidence against it. Okay. Let me erase that. I don't think I need that. Okay. Question 12. Survey was conducted in a large city to investigate public opinion on banning the use of trans fats in restaurant cooking. Random sample of 230 city residents with school-aged children was selected, and another random sample of 341 city residents without school-aged children was also selected. So we have two independent random samples. One of those school-aged children, 94 opposed, of those with school-aged children, 94 opposed the banning of trans fats, and of those without school-aged children, 147 opposed the banning of trans fats. An appropriate hypothesis test was conducted to investigate whether there was a difference between the two groups of residents in their opposition of banning trans fats. Is there convincing statistical evidence between the two populations proportionate at the significance level of 0.05? This is one of those ones we can start just ruling some stuff out. A is like, doesn't make any sense. Yes, the probability of observing is at least as large sample size is greater than, yes, because the probability of observing a difference at least as large as the sample difference is greater than that. Yes, because the probability of observing a difference at least larger than the sample difference. If the two probabilities, so these are like sort of similar, B and C, but it's assuming, that's the part we're going to need here, assuming the null is true. So our null is going to be assuming, P1 is equal to P2, assuming there's no difference. And the not, what are we saying? Was conducting this whether there's a difference. So then we're talking about P1 not being equal to P2. But in order to get our p-value, we have to assume the null. So we can do away with the like B and E because they don't say assuming if the two populations or the proportions are the same. That's that assuming part. So let's go to the calculator and start throwing all this in. So this one's a 2-prop z-test. 2-prop z-test. And the first one we had, what, 94 out of 230, I believe. And the second one we had 147 out of 341, and we're talking about not equal to. So that didn't do anything. Lovely, thank you, wonderful calculator. That I really wouldn't want to do this without you anyway, so we'll just be nice and go on about our business. Okay, so 94 out of 230 and 147 out of 341. Now we get it. So we get a p-value way too high. So this is a no. We do not have evidence that there's a difference. So it's definitely greater than 0.05. Because our p-value ended up being like 0.59. So it happened way more than not. Okay. County manager selected a random sample of 200 residents from a suburban area of the county and a separate random sample of 200 residents from an urban area of the same county. Residents in the sample were asked whether they thought the county should create dog parks where residents can take their dogs to play. And those who were sampled, 41% of suburban residents and 35% of urban residents thought the county should create dog parks. PS represent the population portion of suburban residents who think the county should create dog parks, and let PU represent the population portion of urban residents who think the county should create the dog parks. The county manager will test the following hypothesis. Assuming the conditions for inference are met, which of the following is the p-value of the county? We can just throw all this right back in the calculator, and hopefully it'll actually work this time. So this is also a 2-prop z-test. So our successes, now this one gives it to us in percentages. The nice thing is, I mean, it's pretty easy to do for 200, but if you're not sure, we can do 0.41 times 200 out of 200, and then 0.35 times 200, since it doesn't give us the actual count. Now, yes, we can do 81 and 70. You could probably figure those out pretty quick, but just in case. And it says different than, so we leave it at that. And we get a p-value of 0.216. And there we go. Nice and easy. We like those that we can just throw in the calculator, right? Okay, let's see how many glitches I get when I have to do a free response question. Okay, some boxes of a certain brand of cereal include a voucher for a free video rental inside the box. The company that makes cereal claims that the voucher can be found in 20%. So there is P naught, or P itself, 0.2. However, based on their experiences eating this cereal at home, a group of students believes that portion of boxes with vouchers is less than 0.2. So P is less than 0.2 is going to be our alternate. This group of students purchased 65 boxes of the cereal and investigated the companies. Students found 11 vouchers from the free video rental of 65 boxes. Suppose it reasonable to assume that 65 boxes purchased by students is a random sample of all boxes of the cereal. Based on the sample, is there support for the students' belief that a portion of the box will be vouchered less than 20%? Statistical evidence for you. We're doing the 4 C's, but we can start by just throwing this all into our calculator and getting some answers. So this should just be a 1-prop. Menu, statistics, stat tests, 1-prop z-test. And P naught was 20%. You can put 0.2 if you want. And we got 11 out of 65. And we think it's less than, so we need to change this to less than. Okay, so we got a z-score, we got a p-value, we even got our p-hat, all that kind of fun stuff. So let's start writing this out. Move this over here, I might need to write. So, choose. We're doing a 1-prop z-test for P. Don't forget to define your parameter. True, what does it say? Proportion of boxes with cereal boxes of cereal boxes with a voucher for a free video rental. H naught is P equals 20, HA, P is greater than, less than 20%. Our P hat was what? 0.17. We are not given a significance level here, so we assume 0.05. It's not going to end up mattering because we saw that on the calculator. Our p-value was 0.27 anyway. Okay, check. Random. Stated in the problem. 10%. 65 is less than 10% of all this brand cereal boxes. And large counts. So we're going to use P, our assumed times 65 as a number. I don't actually know what it is off the top of my head, but I'm pretty sure it's greater than 10, is 13 greater than or equal to 10, and 0.80, 1 minus 0.2, times 65, or that was 13, should equal what? 52, which is greater than or equal to 10. All right, calculate Z is stat minus parameter over standard deviation. And we can do stat is 0.17 minus parameter 0.20 over the standard deviation, which is 0.20, 1 minus 0.20 over 65, and that came out to be, from the calculators, negative 0.62, which gives us a p-value it took that long of 0.27. So we conclude assuming the true proportion of cereal boxes with a free video rental voucher is 0.20. There is a 0.27 probability, just gonna do that, of getting a sample proportion of 0.17 or less purely by chance. Now this is a nice one because we don't even really have to have an alpha value. I'm gonna not even use this, because 0.27 is greater than any reasonable significance have to wait till it comes out. There's a lag. Level we fail to reject the null hypothesis and do not have convincing evidence. The true, hopefully this all comes out. The didn't even come out. true proportion is less than 0.20. There you go. A lot of writing, but pretty straightforward. Okay, last question. A survey organization conducted telephone interviews in December 2008, in which 1,009 randomly selected adults in the United States have responded to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Of the 1,009 adults surveyed, 676 responded yes. In December 2007, 622 of 1,020 randomly selected adults in the United States had responded yes to the same question. Do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from December 2007 to December 2008? So changed is not equal to, oops. So we want not equal to this time. So we can, again, best thing to do is just to throw this in your calculator right off the bat. So this is a 2-prop, because we've got 2 proportions. So go back down here, menu, statistics, stat tests, 2-prop z-test. Number of successes for, we'll start with 2008, is what? It was a larger number. I have to look on a different screen. I apologize. 676 out of 1,009. Why is that not typing? 676 out of 1,009. And then 622 out of 1,020. And not equal to, like we said, it just says differs. And so there's our stuff, and it didn't do anything again. Curse you, calculator. I don't know if y'all's calculators actually do that too, where you just type something in and it doesn't do anything. Let's find out this again. So we got 676 out of 1,009 and 622 out of 1,020. We want to stay not equal to. It still didn't do anything. Oh, technology. Hey, what were those numbers again? 676 out of 1,009, 622 out of 1,020. Come on, cross your fingers. Hey, look at that. We got something. We got a really small p-value this time. A really large z-score this time. Should tell us something. You know, we're almost 3 standard deviations away, so we're way out of that 5%. This one didn't give us a significance level again, but it's really not going to matter. So let's look at our thing here. Choose 2-prop z-test for, I'm going to use P8 minus P7. P8 equals 2008. P7 equals 2007. The true difference in proportions of those that responded yes in 2007 or 2008 and 2007. There we go with our little glitches again. H naught, P8 equals P7. Alternative, P8 does not equal P7. We can do this. P hat 8 minus P hat 7 is what? about 0.06. We also can use P combined, which we get off our calculator, also is about 0.64. That should be everything we need. You should see our p-value is so low, we don't even need a significance level here. It doesn't matter if you said 5%, 1%, whatever you wanted to do. Check. We have independent random samples stated. We have two separate ones. We have a different random selection in 2007 and a different random selection. It's not the same group that's being polled twice. We have two independent random ones. And we can assume, here, you can listen to this announcement.
All righty, Spartans. I need you guys to all listen up. We are having a fire drill at 4:13. That's 2 minutes. So students,
that's the silliest thing I've ever heard.
Together right now. When the fire drill goes off, we're going to do like we always do. We're going to exit out the building.
I'm just going to pause this.
Like we always do.
Okay, we'll see if we can get any of this in. So 1,020 and 1,009 are both less than 10% of all U.S. adults. We do the LCC. So I have to use that. So we would do 1,009 times 0.64 and 1,009. I'm going to pause it. I think we're about to get the alarm, and I don't want you to have to listen to that. Neither do I. All right, and we're back. So notice here for the large counts condition, I had to use PC for all of it, and all of those are obviously greater than or equal to 10, so we're good there. All right, calculate. Again, Z equals stat minus parameter over standard deviation. Well, in this case, we've got to do, just to illustrate it, it's p hat 1 minus p hat 2 minus p, oh, sorry, this was 8 and 7. 8 and 7 over square root of p combined 1 minus p combined 1 over n1 plus 1 over n2. All right, so plugging the numbers in, p hat 1 minus p hat 2, 0.06. p1 minus p2 is assumed to be 0 over square root. PC is 0.64. Yeah, and you can put 0.36 or 0.36. But I'm going to put 1 minus 0.64 because I don't care. 1 over, what was it, 1,009? Plus 1 over 1,020. And that comes out to our z-score. We need the z-score and the p-value, put them back up here real quick. Our z-score was 2.82 and our p-value was 0.005. So this is 2.82 and a p-value was 0.005. So we conclude assuming there is no difference in the proportion of those that said yes in 2008 to 2007, there is a, where's our p-value? 0.005 probability of getting a simple difference of 0.06 or more extreme, purely by chance. Need extra space here. Because 0.005 is less than any reasonable significance level, we reject the null and have convincing evidence there is a difference in proportions. Barely fit it on the page. All right, that is it. Hopefully you don't get interrupted with any kind of fire drills. All right, good luck.